everyone, what's up? Yes, so this is the second video of Junior Astrophysicist. Yes, in this video we're going to be learning the basics of time dilation. Now, the big thing is, what is time dilation? Yes, it's a familiar question when you just write it on the board and they tell, I'm going to speak about time dilation. Someone's asking you, what is it? And then you're like, you don't know the definition. I'm sure you won't. So time dilation is the change of time based on various factors. It's not the exact definition, but again, it's for your own understanding. Now, time dilation has a lot of factors on which it can depend and continue to change. So the most basic factor is speed. So yeah, in time dilation there are two factors, speed and gravity. But in this video, we're going to be focusing only on speed because gravity comes only after you learn the general theory of relativity. Not even only the basics is enough, but still, to understand this part of time dilation, you really have to be familiar with the theory of relativity. Yes, right, so time dilation was framed by Albert Einstein. So, when you move fast through space, this is the most important sentence, please don't forget it, through space, you move slower through time. Get it? Now that's a very confusing sentence. When you move fast through space, you move slower through time. Very confusing. I get it. Okay? Yes. So according to this, imagine that you are just standing here. You're not in motion. Now take a look at your clock. Okay? And you can see it ticking at a certain speed, like that. But then imagine you're going at a speed of 200 km/h, which is a bit high. Then you see the clock striking like now. If you notice this, the time becomes slower. Okay, it's a very, not a simple example of going at 200 km/h. It's very a complicated example. So I have found a known example I have made myself. It's not a copy, it's not anyone's idea. To make it very simple, what you do is look at your clock. Now the time's like. Now shake your head at a high speed. Make sure you don't get a headache, okay? Just keep it a bit low, but at high speed like this. Now look at the time. I'm telling you, don't use a digital clock, use an analog clock. You start to see it ticking a bit slowly. You know why? That's because you are in higher speed. Okay? When your head is moving at a very high speed, the time is becoming dilated. Because when you are moving fast through space, you're moving slower through time. When you move fast, time is slow for you. Let me make it good. I don't know if many of you have seen the Flash, the DC Comics guy. Yes, even in the Marvel series, there's this guy called Quicksilver. I don't know about much of Quicksilver, but Flash, according to him, the whole world is in slow motion. I highly recommend you to watch Flash, even if it's a superhero movie, to understand time dilation. That is because when he's very fast, he could see everything in slow motion, literally slow motion. That is again because of time dilation. Understand? He's moving very fast that everything in the world is slow. Very slow. So now there's this point, so in which if you travel at the speed of light, okay? At the speed of light, then it's practically possible for you to see the world freeze. You know, that now there's a guy walking along the road, okay? He's walking, and then some guy over here, he suddenly moves at the speed of light. You can see this guy stop here. He doesn't walk. But if he probably waits for a very long time, I'm not sure about the exact period he has to wait for, but something obviously about a year, I'm sure. Only after a year, you could see him come to this point. That is because this guy is moving at the speed of light, everything is slow. But for this man down here, you would see this guy too fast. This is again time dilation. Yes, it's a bit of a very confusing topic, but you have to understand. Now, in time dilation, when you speak about time dilation, there are a lot of people from that end asking me, is time travel possible? Actually, I really wanted to speak a lot about time travel because I want to make it into a whole new video, but I just want to combine it into this. Because when it comes as part of time dilation, you should really understand that time travel is impossibly possible. You wouldn't really agree to me if I told you that time travel is impossibly possible, but it's, kind of possible. So, time travel is a very common idea for a lot of people. Even some group of scientists are still working on how to use time dilation to do time travel, because this is one of the only sources. Fine, so look at this. A man is traveling at a speed of 50 kilometers per hour. Imagine, okay? He won't be able to time travel. First, because everyone's thinking, if I just go to a time machine, I can time travel. No, it's foolishness, total foolishness, okay? You should understand what that does, what the time machine is doing for that. The only way to travel through time is to go again at the speed of light. And I'm telling you, you go at the speed of light on your street, you'll be faster than the Zane about 20 times faster, but you can't travel to time. There are only two sources in the world for you to travel to time. One, black holes or wormholes, and the other is quantums. I think some people who have seen the movie Avengers Endgame by Marvel Studios would know about the quantum idea. I will be making a new video shortly on time travel through quantums and black holes. But for now, I'm just telling you, it's possible if you go backward in the speed of light through a quantum or in a black hole. It depends on the black hole, okay? Yes. You can probably travel through time. Okay? It's very confusing, but yes. You travel at the speed of light, you travel backward, it depends, you have to navigate it. And then you have to come out of the quantum in the exact time you have to also come to your normal speed. Then that's probably the true time travel. But it's impossible to go to the future, I'm sorry. No one can really try these future kind of ideas. Okay, so when it comes to time travel, there's this paradox called the grandfather paradox. I don't know if many of you have heard the grandfather paradox. Just an idea on basic time travel. Okay, so take a look at this. These are your grandparents. This is your job. Okay? This is your grandpa and this is your grandma. Now they have a son, which is your dad. Okay, this is your dad. Now he was married to a lady, and now that becomes your mom. And now this is you. Okay, this is you, sorry. This is you. Alright, now according to the grandfather paradox of the time travel, if you try to go through time and kill your grandpappy, okay, whatever you call him, he's illuminated. Your grandma wouldn't have met your grandpa, so she would have had a totally different son. That son wouldn't have been married to this lady, and you wouldn't have been born. This is one part of reality. This is the grandfather paradox. But some people have proven this wrong. That is by developing an idea in the grandfather paradox which doesn't support this. You see, yeah, I'm just keeping it like this. So after the time where your grandpappy has been eliminated from the story, there is an alternate reality. I'll just keep it like this. Grandma, grandpa, dad and mom, and then you. You have killed your grandpa. This is one reality, but there is an alternate reality in which your grandpa won't be there, but your grandma has your dad, and then your dad meets your mom, and then you are there. See, there are two kinds of reality. One is the original one, and this is an alternate reality. Though there are a lot of studies on this part of the grandfather paradox because it doesn't really support it, so people are working on it. Okay, fine. So this is about time travel. There is another paradox when it comes to time dilation. So in time dilation, this paradox is known as the twin paradox. What paradox? Twin paradox. This is the most famous idea for time dilation. As you all know, according to the gravitational factor of time dilation, Earth is moving at a slower rate of time. See, the only place where time is at the perfect speed, the perfect flow, is where there is nothing, a total vacuum. Total vacuum, alright? There is nothing. Imagine this is a part of the universe. There are no stars, there are no planets, there are no matter. There is no matter. Here, time flows in the right speed. But now when it is flowing at Earth, again due to some gravitational factors, time is slowed down because gravity can bend time. I will tell you how it can bend time in my next video. But for now, let's just focus on the twin paradox. So now, take this as an idea. There are two twins, okay? Twin A and twin B. They are both of the same age, same identical twins. Just keep it like that, okay? Same body, same everything. But now, twin B is sent off to space. Okay, this is B, and A is on the surface. Now, since I have told you that when you go close to planets and other bodies, due to the gravitational force, time can be slowed down. Okay? So, yes, the person on A would have aged more than the person B. A would be older than B. Okay? This is because when B is in space, he doesn't, what do you say? He doesn't really grow a lot since time goes slower in space compared to Earth. It's a bit faster on Earth, so A would have aged more than B. This is the twin paradox. Yes, you would have wondered, oh, this is only the basics. I'll be taking the advanced soon after I finish with the basics of the general theory of relativity, in which gravity can affect time and a lot, space, time. It's a lot. I don't want to confuse you. For now, this is time dilation. Just keep tuned and wait for me to post my next video so you can enjoy and learn a lot about astrophysics. This is Junior Astrophysicist. Don't forget to like, share, and subscribe, and hit the bell icon for more notifications. Stay tuned and see you on my next video, which I have planned to do on the gravitational factor of time dilation. See you.